Okay, this is number 6, and we have dy dx equals 3 times the square root of x and y, or xy. And again, find the general solution, right? Implicit if necessary, and explicit if convenient of this differential equation. So we want to separate the variables, so we can go ahead and cross multiply. So we have dy equals 3 radical xy dx. And so I want my y's with y's and x's with x's. So let's see, we can, so dy equals 3 times, right? We can rewrite this guy as the square root of x times the square root of y dx, right? From algebra, we remember that the square root of xy is the square root of x times the square root of y. So we can break up the radicals. And let's see, I have my dy here, my dx here. So I'm going to divide by the square root of y. And then I get 1 over the square root of y dy equals, this is a big 1, 3 radical x dx. So I've separated my variables, right? I have a function of y, f of y dy, and then there's my g of x dx. So now that we have it in this this form, right, the separation of variables form, we want to integrate. So, I mean, this is the goal. We want to eventually integrate. But we can simplify these functions, right? We have square root functions, and when we integrate, we've been using the power rule. So let's see if we can rewrite this as a power. So this is going to be, so the integral of, this is really y to the 1/2, but it's 1 over y to the 1/2. So I have y to the negative 1/2 dy. And I can take out the constant, and then this is just x to the 1/2 dx. And move this up. So now when we integrate, we get y to the negative 1/2 plus 1 over negative half plus 1, plus a constant if you want to add those. I'll just go ahead and add it at the very end. So 3 times x to the 1/2 plus 1 over 1/2 plus 1, plus, again, I'll just write c, which really represents a c2 minus c1. So we have y to the 1/2 over 1/2. 3x to the 1/2 plus 1, right, is 1.5, or 3/2, plus our constant of integration. And then again, we can rewrite this, right? This is really 2y to the 1/2, right? When you divide by half, you're really multiplying by 2. Similarly, right, I'm dividing by 3/2, so I'm really multiplying by 2/3. And so we're left with, that's gone, so we have 2x to the 3/2 plus c. And the goal is to solve for y. So we can definitely divide both sides by 2. So that's a big 1. So y to the 1/2 power, again, that's 1. Right, and plus, again, c over 2. I mean, I can just write it as c, or if you want to call it k. I mean, this is just going to be some arbitrary constant, right? And then we just cut it in half. If you want to write, again, k, or different letter to represent your constant, that's okay too, if it's less confusing. So finally, let's solve for y. So I'm going to square both sides. Why am I going to square both sides? Because I want to isolate y, and so 1/2 times 2, right, is just 1. This is going to give us y to the first power, or just y to the 1. And we have x to the 3/2 plus c all squared, right? We solved, oops, for y, right? I didn't take the square root of both sides, so there's no plus or minus. I squared both sides. So here y is defined explicitly. And that's it for number 6.